So hi, hello everyone. So welcome back to my YouTube channel. So there we were learning actually the skills and the tools which are required for DevOps engineer. So for these we have almost covered this AWS and IP addressing and Linux OS we have covered it. So we can actually these all the technologies and skills we required for to be a DevOps engineer. So basically, I have all these technologies I have divided into 12 sections, and each section is in independent of other. So this is what we can learn whatever technology we want. We have just completed till Linux OS, like how Linux is operating and how what is happening. So now I wanted to start with the Kubernetes, and these technologies as well. It will come in series, no problem. I'll be uploading meanwhile. But yeah, for today we are starting Kubernetes. So let's start Kubernetes. What is Kubernetes and how it works? What is the use of Kubernetes? So we'll see today like only basic Kubernetes, and these are the tools which I have explained. Like we need to learn to be a good what you call is uh, the good DevOps engineer. So basically, we have Kubernetes, right? So what is Kubernetes? What is the use of this Kubernetes? So I'll tell you the live example how actually the this is Kubernetes useful and how, what is happening. So this is the first lecture and this is intro lecture. So let's focus on intro. So what happened now? Before, when Kubernetes was not there, so if like when you might this live example you can see in Tata IPL. Okay, this Tata IPL is going on, no? So there we can see sometimes people are live, only few people are live. So you can tell sometime people are only in lakhs people will be there. Okay, but in some time people will be high, that live people will be high. So how they are just not get that application is not getting down. So live in lakhs. Okay, sometime it will be lives in crores. Suppose this is a uh, crore, 1 crore people are there, and this application which we are using our, like if you are using Geo Cinema. So I'm just taking for example. So if you are using GeoCinema, it is not getting down. Whether it is in lakhs people, whether in crore people, whether it will reach more high than how it is happening. So if the resources like people are less, so this application should also work. If people are more, this application should also, GeoCinema application should also work properly. It should not get down. That is the concern. So before, what is happening now? People will make one application which is based on requirement. Suppose they will fix it. Okay, they will fix this application to particular users. Suppose they will fix it like 1 crore users should be maximum. There can be live 1 crore users. So not more than that. So what people that time, what problem we were facing, ki if people are going 1.1 crore or 2 crore people are watching, so when MSD will come, there will be like more people will be joining, and there will be they will be more in live. So people will be live in, like it will go sometime 2.4 crores. So the problem is what, then this application will automatically get down whenever they because it is fixed. So what Kubernetes come into picture. No, here Kubernetes comes into picture to show that whenever there is requirement, suppose people are in Lux, there will be only there will what they will do, they will just make this duplicate of this application, you can say, okay, in simple language, they will just duplicate. So it is not possible when people are joining, then only we will duplicate that. The moment they will join, they, if you are just duplicating it, it means in duplication we can say it is replica in the technology term. So that time if you are going, then application will be down. So what we are doing, we are just setting up our environment likewise. So Kubernetes is doing all these tasks. So what happen if people are in less, this will be removed. If people are in more, then it will be added. If people are more, then it is getting added. This duplication of application, you can tell replica of this application, replica of this container in the terms of DevOps. These terms I'll explain you what it is all. But in simple language, what it is happening, they are making suppose if one application is running, then same duplicate of this application, if people are joining more, then duplicate will be created. Who is creating this? Kubernetes. And we are not doing any manual process. So because of this, the Kubernetes is very useful, very useful when it gives a high traffic to the applications. So this is the like the main purpose of Kubernetes. So whenever, like, it is not about only in Tata IPL or whenever, it is suppose if in airlines, if you are just giving 1 second down, suppose if application is 1 second it is down, any airlines you take, not 1 second, suppose 1 minute, so they will be in loss to they will be getting occurring loss in lakhs. So time is money for them. That's why we are implementing this Kubernetes, and these all these process it is getting automatically. So it is not fixed. So the same thing is reversible as well. Suppose there are less traffic, we don't need four duplication of application, we don't need more container, okay, the container in terms of this Kubernetes I'm telling, but yeah, simple language you can say we don't need this four, right? So what we can do, the people are less, traffic is less, then it will be automatically removing as well. These two application will be removed. And the same time, if again it is getting an increase, then again it will be increasing. So basically, this is what happens in e-com website as well. Even Amazon, Flipkart, Myntra, any website, anyway, this way, these any of the these website if getting down, that means they are losing the like huge business. So so yeah. So yeah, you can go for any this applicable for all the high traffic resources. Like you can tell Netflix, or you can tell any websites like high traffic with high traffic. So Amazon, Flipkart, these all are, they are just operating on this what you call Kubernetes. So, but there are different architecture they are using, different resources they are using, but that is different case. But main concept behind this, how it is not getting down when traffic is high, and how it is managing when traffic is low, how cost effective it is. So this is the main thing. So I have prepared one document, so I'll go through. I'll take you through that. So this is the Kubernetes intro section. Okay, why you need Kubernetes and what it can do. So these are the basics. Containers are good way to bundle and run your application in a production environment. You need to manage the container that run the application and ensure that there is no downtime. Okay, the Kubernetes is not that only purpose. Okay, So there are one more purpose is that whenever there is new release, suppose this application is made in 2009, suppose, okay, and now we have to improve this application. So how we can improve? We need to add these features and all. So adding features and getting new release. So what Kubernetes will be doing now? If we are just shifting from here old version to new version, there is Kubernetes what he will maintain. The application should never go down, right? It should be not win like for 1 second as well. So what happens now? What happens the moment we will release this new versions applications, the old one will be down. When it is getting releasing one by one, then it is getting down by one, means that it is getting deleted one by one and it is getting updated one by one, so that there is no downtime for 1 second also. So this is the concept. This is also useful for Kubernetes. This is what it is explained here. That's how Kubernetes come to rescue. Kubernetes provided with a framework to run distributed system silently. It takes care of scaling and failover for your application. Whenever there is one application will be down, the another will be up, like that. So why unit Kubernetes? What it can do? So these are the things: service discovery and load balancing, storage orchestration, automatic rollouts and rollbacks, automatic bin packing, self-healing, secret and configuration management. These are all the things which I have explained. So I'll focus on more on Kubernetes architecture. So before that, I'll tell you one more thing. Key we have what is this technical term of this cluster, container, pod, and all these thing. I'll explain you properly. Node and all. Okay. So this is I'm just creating box one box to other box. Okay. Yeah. So that you will understand better. So first ever one is you can tell this one is complete system only. Okay, this is called worker node. Inside that, I'll just write first worker node, then coming as container, then coming as what you call in container. Inside there will be pod. In pod we have applications. No, sorry. So in there will be pod. Okay, inside pod there will be container. Then in container we have application. So this is the actually flow. So I'll tell you, this is the cluster and this is the worker node. Okay, and this one is pod, not a container. Okay, and this one is container. Inside container our app will be there here. Okay, this is our actual app application. Okay, so all these thing is you can tell these terms you can, this is the worker node. Okay, this is node. There will be cluster, complete things we call it as cluster. So inside cluster there will be worker node. Inside worker node there will be pod. Inside pod there will be container. Inside container there is app. So app, how it is getting, I'll tell you the flow, how it is getting like executed, how it is. So developer will be writing the code, right? So just go down. I'll tell you, okay. Just new sheet I want. Okay. So new sheet I want. Yeah. Save it. Kubernetes for it. So yeah, in these I'm telling you that so developer will be writing code. So first they will be writing the code. Okay. Then they will push to Git or Git whatever it is, GitHub Central Repository System CVSA, and from there what we will do, the DevOps team it will do, they will start building the code. They will fetch the code. Okay, DevOps engineer, and they will build it using Jenkins. Okay, or if you want to manually build, so build as in manually you can build it using what do you call Maven. So in Jenkins also we need to set up the Maven and it will be built. Built as in we need to create var or jar file. Okay, this is what the build means. Okay, after building process, there will be we need to push it to like by using Docker. So Docker I will be teaching anyway, no problem. Jenkins also I will be teaching. Maven also I will be teaching. These are the simple concepts. But for now, just understand that how flow goes. So so for Kubernetes, like where Kubernetes come into picture after all these steps, Kubernetes will be coming into picture. So just see like how we are going one by one. So after creating war file by using Docker, we need to create images for those, and that image we need to push it to Docker Hub. Push image into Docker Hub. Okay, dockerhub.com, and then we need to like this is still here what we have done. Creating image is nothing but we have created the container. This is just remember this thing we have this is containerized now. So we have just made it in a box, in a dabba. Just you can say in a dabba we have made it uh, in one place. We have put it everything in one place, just you can say. And this is what called, and this one place we need to send it to somewhere in web is where in Docker Hub. This is a like central repository. This is repository. Okay, central repository. So how we are pushing the code into GitHub all along. So likewise it is pushing to dockerhub.com. There is one website. So now what we have to do, after pushing this, Kubernetes comes into picture. How comes into picture Kubernetes? So I'll explain you that now. So if you have pushed till here, if you have done, this is the prerequisite of this Kubernetes. So till Docker Hub you have pushed the your image, means your application as you made it container and you push it to that container is now staying into dockerhub.com. Now Kubernetes comes into picture where Kubernetes what you will do, uh, it will just you have to write one YAML file, manifest file, okay, which will be in YAML form. Manifest file is nothing. We are writing one file which is in YAML format, that language, and it is very easy. I'll tell you. I'll explain you completely. It is not a big deal. So it will be in YAML format, and we are writing in that, and there from what happens now from there these image will be image that for that image pod will be created. For that image pod will be created and deployed at the same time. So there is some file. I'll tell you how. I'll explain you. So this is what the happening from this you can tell. So we will be just deploying like that. And we were whatever we were writing, no, this all this replica means duplication and all. We will writing in this for file only. Just one file and one command, and your duplication application, all the rules and all we will be writing here. Duplication of applications and scalability, scaling, all the things is written in this file only. So yeah, so this is the manual, this is the process actually. So here, till here, and there is two tools coming under. Okay, from here to here, you can tell from here, it is coming Jenkins. This part is for Jenkins. Automatically Jenkins will be doing this thing, and from here to here, this part is for Docker. So Docker will be doing this job. Now Kubernetes comes into picture. Kubernetes will be doing all this duplication of app scaling and whatever, according to this file. What you call is according to this file. Okay, manifest file, whatever we have written, we will write the rule and all. So this is actually rule file. How applications should work, how it is happening. So you might understood the how we are doing, how it will be any project. The process is same. Okay, this is the flow of working flow of Kubernetes. Okay, so I made it very simple, so I hope you can understand. So now I'll tell you about the architecture. So there are control plane. Control plane is what? Master node. This is called master node, and these nodes are worker node. They are working under this. So in control plane there will be four things: etcd, control manager, API server, and scheduler. And for worker node there is kubelet and q proxy. So these two things are there. So what it is doing, etcd is doing, you can say, etcd is just put like it is the storage kind of thing. It is just storing the sensitive information. And API server is all way it is connecting to each and everything. API server, whenever you are writing some rules here, no, in manifest file, that rule should go to API server, and API server talk to each other, ki what have to do and how to do. And he is not doing anything. He just tell ki this is the request, you do what you want. Okay, so likewise it is going. So control manager is managing whatever there is a request accordingly. So scheduler is scheduling the task, like when to do, when to close, when to delete the things, whatever rule we have written accordingly. Kubelet is just to interact with this master node. Okay, to worker node. He is making communication between them. He is establishing the connection actually. K proxy is just putting for IP servers which node should be which IP, and which things would be what. So these complete details I'll be sharing this in the like description section. So yeah, that's all for today. Thanks for watching. So I think it is quite long video, but yeah, thank you, it is useful. If it, please like and subscribe the channel if it is useful. Thanks.